Part 2 of lesson 1.6. Now we're going to talk about clearing fractions in equations. So for part of it we were doing the distributive property and then we were solving, and now we're going to clear fractions. So if you have fractions in your equations, it's best to clear them out of there and get them out of there. So often an equation modeling a real situation will involve fractions. If you want to clear an equation of fractions, multiply each side of the equation by a common multiple of the denominators. So we're going to figure out a common multiple of the denominators and multiply everything on each side of the equation by that common multiple. Let's do 2 examples so you can see how that works. Example 3a. In Game 5 of the 2006 NBA Finals between Miami and Dallas, Dirk scored 1/5 of Dallas's points and Josh scored 1/4 of Dallas's points. The rest of the Dallas Mavericks scored a total of 55 points. How many points did Dallas score? So let's say that P equals total points scored by Dallas in the game. So Dirk, they said, scored 1/5. So he's 1/5 of P, the total points. Josh scored 1/4 P, so 1/4 of Dallas's points. And everyone else, all others, they scored 55 points, and that's what it says there. So in order to figure out the total P, we can say that total P equals what Dirk scored plus what Josh scored plus all the others, to add it all up. Now you see we have fractions and we don't want the fractions, so we're going to multiply everything by a common multiple of the denominators. Well, if you look at one fraction, it has 5 in the denominator and the other one has 4 in the denominator. A common multiple of those of 5 and 4 is 20. So we're going to multiply everything by 20 on both sides. And that means every part of it. So we can say 20p equals 20 times 1/5 p plus 20 times 1/4 p plus 20 times 55. We can do 20p equals 20 times 1/5 p is the same as 4p, because 20 divided by 5 is 4, plus 20 times 1/4 p is the same as 5p, because 20 divided by 4 is 5, plus 20 times 55 is 1100. Now let's combine like terms. We have 20p equals 4p plus 5p is 9p, plus 1100. We can subtract 9p on both sides. So we have 11p equals 1100. If we divide both sides by 11, p equals 100. That's the total points scored by Dallas. Dallas scored 100 points. We could also figure out how many points Dirk and Josh scored, because Dirk scored 1/5 of P, so 1/5 of those 100 points. So he scored 1/5 of 100 is 20 points. And Josh scored 1/4 of those 100 points, so he scored 25 points. Okay, let's work through another example of clearing fractions in equations. Suppose during a 2007-8 regular season NBA game involving the Boston Celtics, Kevin scored 1/3 of Boston's points, Ray scored 1/4 of the points, the rest of the players scored 60 points. So let's go through a similar process. This time P equals total points scored by Boston. They said Kevin is 1/3 P, because he scored 1/3 of the points. Ray equals 1/4 P, because he scored 1/4 of the points. And the rest, they scored 60 points. So we can say P equals what Kevin scored plus what Ray scored plus the rest of them. That's our equation to model the situation. Now let's solve it. Let's get rid of those fractions. We clear them out by finding a common multiple of the denominators. So we have 3 and 4 as denominators. A common multiple would be 12. So we're going to multiply everything by 12. Everything, all of it. So 12 times p is 12p. And we have 12 times 1/3 p plus 12 times 1/4 p plus 12 times 60. So let's clean that up a bit. 12 times 1/3, 12 divided by 3 is 4, so we have 4p, we can't forget that p, plus 12 times 1/4, 12 divided by 4 is 3, so we have 3p, plus 12 times 60 is 720. Let's combine our like terms. We have 7p plus 720. Let's subtract 7p from both sides. So we have 5p equals 720. Let's divide both sides by 5. And p equals 144. That's how many points scored by Boston. And then if we want to figure out what Kevin scored, we could say Kevin scored 1/3 of p, so 1/3 of 144. So he scored 48 points. Ray scored 1/4 of p, so 1/4 of 144, so he scored 36 points. And the rest scored 60. If you added all that up, 48 plus 36 plus 60, it should equal 144, which is the total p. And that's how you can check your answer. The last part of this, we're going to talk about the opposite of a sum theorem. For all real numbers a and b, negative a plus b equals negative a plus negative b equals negative a minus b. In other words, let's use some numbers to help understand that better. So we have negative a plus b. So let's distribute, or let's put, and this is part of the distribution, but we're distributing a -1, I like to say. So pretend instead of just negative, it's a -1 in front of the parentheses. And you could say 3 plus x. We'll use a number and a variable. So we can distribute the -1 to the 3 and to the x. So it would be -3, because -1 times 3 is -3, and then -1 times a positive x is a negative x, so minus x. Or you could write it as -3 plus a negative x. That is the same thing, and that's what they're saying for both of these. Just using numbers instead of a's and b's. So let's do 2 examples with that. For a, suppose g of a equals 3a minus 7 minus 5a. For what value of a is g of a equal to 12? So we're going to plug in 12 for g of a. So 12 equals 3a minus 7 minus 5a. So we need to do some distribution and distribute that -1 that's right outside the parentheses. So 12 equals 3a. So we're distributing a -1 times 7. So -7. And a -1 times a -5a, so it would be plus 5a. So now let's solve. Let's combine some like terms. 3a plus 5a is 8a minus 7. Let's add 7 to both sides. We have 19 equals 8a. And then let's divide both sides by 8. And we have a equal 2.375. Okay, the next one. Suppose h of y equals 13y minus 26 minus 3y. For what value of y is h of y equal 100? So we're going to say 100 equals 13y. And we're going to distribute that -1. So -1 times 26 is -26. And -1 times a -3y is a plus 3y. Now let's solve. Let's combine like terms on the one side. We have 13y and 3y, so that's 16y minus 26. Let's add 26 to both sides. So we have 126 equals 16y. Let's divide both sides by 16. And y equals 7.875.